Now we're on page 29 of the notes, and we're going to look at these two examples. A rectangular, I should say, piece of cardboard is 2 centimeters longer than it is wide. So let's draw a sketch of what that looks like. It's 2 centimeters longer than it is wide. So it looks something like this. We don't know how wide it is, so let's say it's x centimeters wide, and then it's x plus 2 centimeters long. It's up to you guys to decide which way length goes and which way width goes. From each corner, a square of 2 centimeters is cut out. So I'm cutting out 2 from here, cutting out 2 from here, I'm cutting out 2 from here and 2 from here. And how has this changed things? Well, now I have a shape that looks like this. With 2 centimeters cut from each corner. Initially, this was x wide, but now I have to subtract 2 from each side here. And so this bit that's left over is x minus 4. This was x plus 2, but again I have to subtract 2 from here and 2 from here. So this is now x minus 2. And each of these little flaps are 2 centimeters themselves. And what happens is this gets folded up to form an open box. And hopefully you can visualize that. So I have a box in 3 dimensions, and when I fold it up it looks like this. Now what are the dimensions? I have this short side here, x minus 4 centimeters, this slightly longer side here, 2 centimeters longer, x minus 2, and the height is 2. When it's folded up, the volume, which is length by width by height, is 70 centimeters cubed. Well, we know the length in terms of x, we know the width, and we know the height. So if we multiply these 3 together, set it equal to 70, we should be able to solve for x and then calculate the dimensions in numerical form. So 2 by x minus 2 by x minus 4, x minus 4 is equal to 70. And multiplying that out, that's 2 by x squared minus 4x minus 2x plus 8 equal to 70. That's 2 by x squared minus 6x plus 8 equals 70. You can choose to either multiply that 2 in, or why don't we just divide across by it, because 2 goes into 70. So x squared minus 6x plus 8 is equal to 35. Bring everything to one side. X squared minus 6x, 8 take 35, minus 27 is equal to 0. And we look for 2 numbers that add to give us minus 6 and multiply to give us minus 27. And 3 and 9, minus 9 and plus 3. So either x is equal to 9 centimeters or x is equal to 3 centimeters, minus 3 centimeters. Now, x is width. If x was minus 3 centimeters, this would be minus 7. We can't have a negative distance, so we discard this answer. Can't have a negative length. So the only valid answer is that x is equal to 9 centimeters. We haven't answered the question yet. They want the length, the width, and the height of the box. Okay, so the length was the long one, but it's not, of the cardboard, sure I'm answering the right thing. The length was x plus 2 and the width was x, so that means that the length of the cardboard was 11 centimetres and the width was 2 centimetres less, 9 centimetres, and that's my answer. Okay, and move straight on to the next type of question that we want to look at. The next type of question is a quadratic, but it doesn't look like one. In fact, before we even do this, I'd like to do a slightly more straightforward question. You should hopefully have done something like this in junior cert. Just getting some paper here. So if we have a fairly straightforward quadratic equation that we're solving, x squared plus 5x plus 6 equal to 0, okay? And we solve that by factorising x plus 3, x plus 2 equal to 0, so x is equal to minus 3, or x is equal to minus 2. Now there's a follow-up substitution question. Hence, solve this. 2y minus 1 squared plus 5y minus 1 plus 6 equal to 0. I don't know if you can see, but this has, that should be a 2 in front of there, this has 2y minus 1 everywhere this had x. So because this matches the same pattern, as my initial quadratic, we can say let x equal to 2y minus 1. And then we can set each x solution equal to 2y minus 1 and solve for y. So what we get is that when x is equal to minus 3, from up here, 2y minus 1 must be equal to minus 3, 2y is equal to minus 2, and y is equal to minus 1. When x is equal to minus 2, 2y minus 1 is equal to minus 2, 2y is equal to minus 1, and y is equal to minus a half. Now I do recommend that you might put in an extra sheet into your notes with an example like that. Let's do one more that's a little bit straightforward. If we have a question like this, solve 3y plus 2 all squared minus 6 times 3y plus 2 minus 27 equal to 0. How would we solve an equation like this? So rather than us starting with the known quadratic, the normal quadratic equation, we're starting with something that looks a little bit strange. And we're going to say let x equal to 3y plus 2. Then we can rewrite, just move this around, and so now we can rewrite the equation, and we rewrite it as x squared minus 6x minus 27 equal to 0, and the factors of that, I picked one that we just used, x minus 9 and x plus 3. So x is equal to 9 and x is equal to minus 3. And then we use both of those answers, so hence either 3y plus 2 is equal to 9 or 3y plus 2 is equal to minus 3. So when 3y plus 2 is equal to 9, 3y is equal to 9 minus 2, which is 7, and y is equal to 7 over 3. And it's fine if we get a fraction answer. We'll often get very messy answers for the second part here. Or 3y is equal to minus 5 and y is equal to minus 5 over 3. Now, I'm going to stop there for today, and tomorrow we'll look at example 6. Okay, so make sure you understand example 5. Take down these 2 extra examples, make sure you understand those, and I'll put up some homework in Google Classroom as well. Okay, thank you very much.